Hi there, everybody. This is a solution to problem 3 in page 2.5, which is applying your knowledge of analytic geometry to larger problems. Here's what it looks like. What you should do is pause the video now and read over the problem. Here's the diagram and the plan that we created in class last Friday. We're going to find the midpoint of GH, and we're calling it point M, which is right here. We're going to find the slope of MB, which is the green line, and find the equation of the green line using y equals mx plus b. Then we're going to know the coordinates of point B because that'll be the y-intercept, so that'll be easy. Then we're going to calculate the two red distances shown on the diagram. And in this one, I've labeled the first distance dGB and the other one dBH. And then we're hoping that those distances will turn out to be equal because that's what we're trying to prove. So here we go. First thing we have to do is find the midpoint of GH. So, midpoint of GH. We can use the midpoint formula. And the coordinates of GH are on the screen. You can see them. So we'll have -1 plus 7 over 2, comma, 5 plus -1 over 2. And that'll give us 6 over 2, which is 3, comma, 4 over 2, which is 2. So now we know that M is 3, comma, 2. And you want to put that on your diagram once you figure it out. So there's the point we figured out. Okay, step 1 is finished. Number 2, find the slope of MB. Okay, I'm going to call that little m, and I'll call it MB. How do we figure that out? Well, that will be the negative reciprocal of the slope of GH. So I really do have to figure out the slope of GH first. MGH. So the slope of GH, I would use the old slope formula. And again, the coordinates are on the screen so you can see them. I'll do 5 take away -1 over -1 take away 7. That gives me 6 over -8, or -3/4 in lowest terms. And that means that the slope of MB, which is the negative reciprocal of the slope of GH, would be 4/3. And the reason it's the negative reciprocal is the lines are perpendicular, and this is the symbol for perpendicular. So I'm showing my reasoning there with that. Okay, we've done that. Find the equation of MB using the equation of a line. Okay, so MB is, and we use our equation of a line, and we're going to substitute either of the points. No, we only know M. We don't have 2 points. We only have M, so we have to use 3, 2. So 2 goes there and 3 goes there. The value of the slope is 4/3, and B we don't know. So here, the 3 and the 3 cancel because we're multiplying. So we get 4. 2 equals 4 plus B, therefore B must equal -2. Okay, so now we know that the coordinates of B have to be 0, -2, because, as you recall from the diagram, B is a point on the y-axis. So 0, -2, we just figured out the coordinates of B. Okay, so we are at this stage here. Starting step 5, which is calculate the distances. All right. So first, let's do this in red. We have distance from B to G, and we have a formula for that. And I'm going to skip some steps here because this is just going to be slow. So skipping all the steps of the calculations, you can see that both distances turn out to be √50. Therefore, B is equidistant from the 2 points.